This is skill 8.2, regular polygons. So in the last lesson, we talked about what a polygon was. Polygon is a figure that has straight sides and it is connected. It's a closed figure. So a regular polygon is just something that's a little bit more specific. A regular polygon is a polygon that has all sides congruent and also all angles congruent. So it's a special one. It's one that's very symmetrical, very nice, and very fun to work with sometimes. So a couple examples here. A regular triangle. There's a picture of a regular triangle here. Normally we don't call it a regular triangle. We've talked about this one. If you have a triangle with all three sides congruent and all three angles congruent, we would typically call that an equilateral triangle. So we've already seen some regular polygons already this year, okay? Kind of the same idea with this next one. If you have a shape that has 4 congruent sides and 4 congruent angles, those 4 congruent angles are actually going to end up being 90-degree angles, and we're working with a square. Okay, so you could technically call it a regular quadrilateral. We don't usually do that, but that would be another name for it. Okay, and then the last one, we could call it a stop sign. Not a very technical term, but I'm gonna write it down anyway. A stop sign has 1, 2, 3, 4, 5, 6, 7, 8 congruent sides, and it also is going to end up having 8 congruent angles. So a stop sign is an example of a regular octagon. All right, moving on to a couple of examples. So with regular polygons, we can actually use some math and use some algebra to solve for some things. So in each of these examples, we're going to solve for x, we're going to solve for y, and then we're going to find the perimeter. And I kept this first one fairly basic, and I even color-coded it to make things easier. But what we're working with here is a regular, I'm going to write this down. I didn't tell you this before, so I'm telling you now. It is regular, so all of the sides are going to be congruent, and all of the angles are going to be congruent. And it looks like there are 6 sides, so it's a regular hexagon. All right, so if the sides are congruent, then 32 is equal to 6x plus 2. And if we go ahead and solve that, we're going to end up with 30 equals 6x. Can divide by 6, and x is equal to 5. And then we can hop over to y. And y is part of an angle, and we know that the angles are congruent to each other. So we can set up a separate equation that says that 3y is equal to 120 divided by 3, and y is equal to 40, or 40 degrees. We kind of do need the degree sign, so I'm going to go with 40 degrees. We didn't have a degree sign in the original problem. So we got x solved, we have y solved. Now for perimeter, we didn't talk much about perimeter this year, but I think we probably remember that. Perimeter is just equal to your side length times your number of sides. Side length. And remember, we already talked about what n is. N is the number of sides in a polygon. So in our situation, our perimeter is equal to the length of one side, which was 32, times the number of sides, which was 6. So we just need to figure out what 32 times 6 is, and it's 192. So our perimeter is 192. There aren't any units in this case, so we'll just leave it. All right, so we'll start example 2. This one looks like it's going to be a regular pentagon. So let's start by writing that down. Regular pentagon. You wouldn't know that it's regular unless someone told you that it was. So I'm telling you that it is regular, meaning all of these angles are going to be congruent, and then all of the sides are going to be congruent. And it's a pentagon because it has 5 sides. So just like we did in the last example, we're going to solve for x by setting those 2 sides equal to each other. So 12x minus 1 equals 2x plus 9. From there, we have a lot of options about what to do. I usually like getting all the variables together on one side of the equal sign first. So that would give me 10x minus 1 equals 9. And then I would add 1 to both sides. So 10x equals 10. Divide each side by 10. 10 divided by 10 is 1. So x has to be 1. Okay, now what I'm going to do with that too is I'm going to substitute it back into the equation. So I'm going to do 12 times 1 minus 1 to figure out what the side lengths actually are and to check my work at the same time. So 12 times 1 is 12. 12 minus 1 is 11. So on that one, I got that a side length is 11. Same thing over here. I'm going to do 2 times 1 plus 9. Well, 2 times 1 is 2. And 2 plus 9 is 11. So that's good. X is 1, and then each side is 11. So when we go to do perimeter, I think I'll do that next. Remember, perimeter is the length of one of your sides, which is 11, times the number of sides, which is 5. And 11 times 5 is 55. And then that just leaves us with solving for y. So this one looks a little bit weird, but the angles should be congruent to one another. So y plus 8 should be equal to 208 minus y. And we haven't done a lot of equations that look like this, but it's the same thing. We just follow the same process. First thing I would do is probably get the y's to the same side of the equation. If it helps you to put 1s in front of them, do that. I think that's easier for some students. Now you can see that if you add 1y to both sides, 1y plus 1y is 2y. Bring down our plus 8 and our 208. And then subtract 8 from both sides. So 2y is 200. Divide by 2. And y equals 100. And again, we could totally check our work. We could plug it back in. We could do 208 minus 100 is 108. And we could do 100 plus 8 is 108. We can see that both of those angles do in fact end up being congruent. So in summary, if you want to write this down, I would. In a regular polygon, all sides are the exact same length and all angles have the exact same measure. And if you can remember that, then you should be able to work your way through and find your missing sides and angles in your perimeter.